Yes, class. So in the last class, for two waves, we had seen the equation of the resultant displacement, equation of the resultant amplitudes of two waves. I'm audible now. I hope I'm audible to all of you.
Yes, teacher.
Okay. So yes, so resultant of amplitude wave that we discussed. Apart from that, we had seen what is the magnitude or how do you calculate the resultant intensity. If you have two waves, then what is their resultant intensity? So this question also we had done. Now fringe width, this topic we have to do. Before we do fringe width, we have to understand what is the linear separation of central bright fringe from any of the fringes that we take. So see, for that, let me draw this. So see, now again, Young's double slit experiment is there. So double slit I have taken. This is source 1 part. This is source 2 part. Slit 1, slit 2, sorry. And here is the main source. This is the source. And these are the slits. So double slit. Let's say that this separation between both the slits, this is small d. So from the midpoint of this, if I take the middle point of this, so this will become what? D by 2, and this will become D by 2. This half part will become D by 2, and this half part will become D by 2. Fine. Now from slit 1, that is the slit 1, one wave is incident. This is one wave that is incident. Now from source 2 also, one wave will be incident. And they'll superimpose each other at a certain point. Fine. This is, let's say, some point P. Now see, at the center, what will happen? At the center, did we discuss this or not? I don't remember. Again, I'm telling you. From the center, you obtain the bright fringe. Remember, fringes, I have discussed it with you. I'm discussing it again. Listen carefully. Whenever two waves superimpose on each other, if they constructively interfere with each other, that means if somehow the crests of one trough, the crest of one wave overlaps with the crest of another wave, and the trough overlaps with the trough, then it results in the greater amplitude, greater intensity that we have discussed. So this is the case of bright fringe. You get bright bands. Fine. Bright colored bands you can obtain depending on the source which you have. Then you, at the center, you obtain a very bright fringe. Fine, a very bright band you obtain. Then on either sides of it, you obtain the first dark band. Then on the either sides of the dark band, you obtain your bright fringe. Then dark, then bright. Like this continues. So at the center or at this point, here at this point, you obtain, this is known as central bright fringe. The center one, this is the central bright fringe. Central bright fringe. Now see, let's say for the derivation part, I'm marking this point as N, and for this derivation part, I'm marking this point as M. Now, what are we calculating right now? I'm not calculating fringe width first. I want to calculate Yn. Now, Yn is what? See, Yn is linear separation of nth fringe, some Ynth of nth fringe from central bright fringe. Now see what is happening over here. Central bright fringe is there. So this is my reference now. The central bright fringe, this is my reference now, right? Now I'll be obtaining dark fringe here, then I'll be obtaining bright fringe here, then dark fringe here. Like this, all the fringes will be present. Suppose, let's say I'm talking about this one, this fringe that has been formed at this point, fine? So for this fringe, there will be a certain separation from the central bright fringe. So that is known as the linear separation for any nth fringe. Let's say I take fifth dark fringe. So fifth, this is the central bright, let's say. So one, first dark, second dark, in between brights are there, then third dark, fourth dark, fifth dark is there. So this separation, this will be known as Y5. That is the linear separation of the fifth dark fringe from the central bright fringe. So Yn, what we are trying to find out the expression of which is the separation of any of the fringes. It can be bright, it can be dark, but separation from where? From the central bright fringe. From the central one, wherever you have to obtain. Fine, in the wall, you will obtain a central bright fringe that at any point, let's say this I have taken at this point P, the lights, both the waves are overlapping. So let's say this is I am trying to calculate. Let's say this is Yn right now. From the central bright fringe, this is Yn. Now n can be any number and n can be valid for any, be it dark fringes or your bright fringes. Fine. Now see, for the derivation part, if you notice here, this part was d by 2. So what will be this Pn? Yn minus d by 2, right? This part, Pn. Similarly, if you look at this path, this was d by 2, right? This is d by 2. So this complete entire will become Yn plus d by 2. Now, why did we discuss this? Path difference and phase difference we have already discussed. Now see, in case of phase difference was the sinusoidal angle variation that was present after sine that used to come. Path difference was a separation between both the waves that were coming. The path that was covered by both the displacements. Fine, both the waves that was covered by it. So if the first one is S1P, second one is S2P. So S1P is the path of the first wave, S2P is the path of the second wave. So their difference will give me whatever is the difference in their path. So I'll start from here only. X is equal to S2P minus S1P. Now I want to find out what is the value of S2P and S1P. So for S1P and S2P, let's start with S1P. So if you look at the triangle S1NP, this triangle, this smaller triangle that has been formed, this triangle, this is S1, this is N, this is P. So S1NP, this triangle, fine. So if you look at this triangle and you apply Pythagoras theorem, so one more thing, yes. Small d is the separation between both the slits. Separation between the slit and the screen where the waves and bright fringes, all these are obtained. This we have taken it as capital D. Fine, I have written it also here, but I forgot to discuss it. Now see, in this triangle, what will happen? This is Yn minus d by 2 because this entire, this part, this was Yn. See, this part was Yn over here. If you look at this path was Yn. Now see, if this path is Yn here, this is Yn, this complete is Yn. Now, and what about this path? This is simply Yn minus d by 2. Why? Entire was Yn. This part was d by 2. So from Yn, if you subtract d by 2, what will you obtain? Yn minus d by 2. Just exactly this path. Similarly for PM, if you look at PM, so this is Yn and this was d by 2. So PM will entirely become Yn plus d by 2. This whole length, this will become Yn plus d by 2. Whereas this length will become Yn minus d by 2. And this is the base. So base is what? Base, the separation between the slit and the screen. The base is the separation between the slit and screen. So if this is the separation between it, that is capital D. And S1P is unknown that we are trying to find out. So S1P will be equal to what? In triangle S1P, your hypotenuse will be equal to perpendicular PN. And what was the name of the base? S1PN. S1N, right? So that becomes S1N whole square. Now keeping everything in the main formula, this S1P whole square will be equal to what? See, S1N is what? Capital D whole square plus Pn is what? Pn is Yn minus G by 2 whole square. Fine, this is Yn minus G by 2 whole square. Now let's take root on this side, because just to remove this power 2. So S1P will be equal to D square plus Yn minus G by 2 whole square is there. But this entire term is to the power half. Fine. Now see, we can multiply this half also, so that this here will obtain D only. So S1P will be equal to D square to the power half plus Yn. Let's do one thing. Okay, let's keep it till here first. Yn minus D by 2 whole square. This to the power half. Now let's do one thing. Let's take D common. D common, or let's take D square common. Let's take D square common. Let's keep it as it is. If we take D common from here, let's take D common. So what is left? 1 is left from this term, because this gets cancelled. D is over here. 1 plus. So Yn minus D by 2 whole square is there. But in order to take this common, we have to make this D square. Then only, when this will get multiplied, nothing will be left. When D square will actually get multiplied here, nothing will be left. So this term to the power half. Now, why did I intentionally make it such complicated? Why did I take S1 from this expression, capital D common only? Because I wanted to obtain this 1 plus something to the power n. Now see, if you all have studied binomial expressions, you must have studied in case of binomial expression. Binomial expression. 1 plus x to the power n is there. If any equation is in this form, then you write 1 plus nx. This is not differentiation or integration. The rule is different. But this is very much related to your this is exactly binomial expression only. So all those who have mathematics, you will be studying in detail, or you must have studied in detail binomial expressions and how to solve it. But right now, this much is enough for the solving in your physics. So S1P is equal to capital D common. From here, 1 plus. Now n is what? See, 1 plus x to the power n. So 1 plus x to the power n. That makes it 1 plus nx. 1 plus n, then x. Fine, this is the entire term that is left. So S1P's value I have it. I do not have the value of S2P. So for S2P, I look at the bigger triangle. This triangle. S2PM, if you look at this triangle. So hypotenuse is S2P, base is again S2M, that is capital D, and the perpendicular, this is Yn plus D by 2. So same steps will be repeated for it, just the triangle will be different. Now in triangle S2, what was the name? S2MP. So S2P whole square will be equal to S2M whole square plus PM whole square. So S2P whole square will be equal to S2M is again capital D, the separation between the slit and the screen. This is capital D square. Now instead of just the difference will come, that instead everything will remain the same. Instead of that positive sign, instead of that negative sign, a positive sign will come. This time it will be Yn plus D by 2 whole square. Now we'll repeat all the steps, same steps. See, this will be half. S2P will be equal to, this will become D. If you take D common, yn plus D by 2 whole square by D square to the power half. Half will be there. Now again, we'll apply same thing, binomial expressions we'll apply. So if you apply binomial expression, if binomial expression is applied, now S2P's formula will become D 1 plus again half yn plus D by 2 whole square by D square. Now equation of S2P is also obtained. So S2P is obtained, S1P is obtained. Can we get our path difference now? Path difference was what? S2P minus S1P only. Since we didn't have the values of these, that's why we were having difficulties. So see, now X will be what? This will be S2P minus S1P. So S2P is here in front of you. So this becomes G 1 plus yn plus D by 2 whole square. 1 plus D. D is out of the bracket, no, for it. So this is what? This is S2P, the longer one, minus S1P, the shorter one, that is D 1 plus half yn minus D by 2 whole square by D square. Fine. Now we just have to solve this. So if we multiply it, so X will be equal to what? Let's say capital D common as well. So 1 plus half. Okay, half is also there here. Half will also be there. No, binomial expressions we have already used. So half yn plus D by 2 whole square by D square. This will become minus 1 minus half yn minus D by 2 whole square by capital D square. And D has been taken common from here. Now see, 1 minus 1. Leave half as it is because we need half for our answer for our calculation, right? So what is left now? Okay, take D square also. 2D square also we can take common. Half D square we can take it common. So if you take 2D square here, so what will be left? Yn plus D by 2 whole square minus yn minus D by 2 whole square. That's why we couldn't erase this negative sign. Otherwise, it would have got cancelled. And you'll be stuck here at this step only. So that's why we couldn't cancel. So this is D 1 by 2D. And now we'll apply the identities, the normal algebraic identities that we have, a plus b whole square and a minus b whole square. So X will be equal to what? See, 1 by 2D will be remaining. A plus b whole square, right? This is a plus b whole square. So a plus b in a plus b whole square, a square yn square plus b square we write. That makes it plus b square, that is g square by 4. A square plus b square plus 2ab. Fine. Now minus a minus b whole square. I will be multiplying minus. So in a minus b whole square, first it is a square. So that will become minus a square because of this negative sign. Then plus b square, again it will become minus b square. And minus 2ab is there, but minus into minus will become, here this will become plus 2ab. That is plus 2yn d by. Now some things will be cancelled over here. Yn square, d square by 4, d square by 4. So X will be equal to 2 will get cancelled, 2 will get cancelled. So YND plus YND becomes 2YND. 2YND divided by 2 capital D. So 2 will get cancelled. Now from here you have the expressions of both X as well and Y as well. So from here, x will be equal to yn small d by capital D. So even if you require path reference and you have the linear separation, you can use this. Otherwise, you in any way have the formula yn from here, that is equal to x capital D by small d over here. Fine. This much is remaining. This much is there. Also one thing. Now using this, you can calculate this for bright and dark separately. Now you have the general formula. No, yn is equal to x capital D by small d. This is the general formula for any fringe separation from the central one. First, tell me, till this equation is clear to you?
Yes, ma'am.
Okay. Now see, this equation is a general equation. No. What is the meaning of yn? What did I say? From the central bright fringe, separation of any of the fringe. That linear separation, that is known as yn, what we are calculating. But fringes are not constant, or fringes are not uniform. You know, some fringes are bright, some are dark. So we cannot use this formula just for every quantity. No, for both the quantities, we can write it separately. So for bright fringe, like if we use this for bright fringe, we know the value of x for a bright fringe. X is equal to n lambda. So yn will be equal to what? X, that is n lambda. So x capital D by small d. This is the formula for a bright fringe. Specifically, if you want to use it for a bright fringe, n lambda capital D by small d. That is x capital D by D only. But it's just that since we have different values of pathways for bright and dark, so we use. Take any example. Let's say first bright. If I ask you to calculate first bright fringe, fine, I'm asking you to calculate first bright fringe. So what is meant by this? First bright fringe means yn is equal to 1. So that is lambda capital D by small d. Right. Let's say I'm asking you to calculate second bright fringe. Second bright fringe is separation from the central maxima. That is y2. So that becomes 2 capital lambda by small d. This is for the bright fringe. Supposedly, let's say I am asking you to calculate it for dark one. So will you use the same thing? No? For dark, you will have different. Because you know for dark fringes, you have the different path difference formula. So if you have dark fringes, x is equal to 2n minus 1, lambda by 2, all these things were discussed in the last class on Tuesday. X, phi, intensity, resultant wave, all these things. So all those who have missed the class, I think all of you were present. Nobody is there who was not there. Akifa, Atif, Fatima, Hamza, Hanifa, you were not there, I think. On Tuesday's class, were you there, Hanifa? Hiba, Huzaifa, Krishna, Kulsum, Sara, Zain. All of you were there. So you should be able to relate. And all those who have revised, they'll be able to understand it. Now let's keep this value in y. So y will become, yn is what? X capital D by small d. Capital D means separation, linear separation. Small d means slit separation. So x, that is 2n minus 1 lambda by 2 capital D by small d. So this big is the entire formula for dark fringe. Fine. Now you can take any example. For example, if I ask you to calculate the first dark fringe, I'm asking you to calculate the first dark fringe. So first dark fringe will be what? Y1 will be. This becomes 1. So 2 into 1 is 2. So 2 minus 1 will become 1 again. That is lambda capital D by 2d. Fine? This is lambda capital D by 2d. Or even let's say second dark. Let's say I'm asking you to calculate the second dark. Find second dark fringe. So here in this formula, you will put y2. That makes it 2 into 2, 4. 4 minus 1, 3. So 3 lambda capital D by small d, like this. So this is a standardized formula from which you can calculate any of the fringes length that you want to calculate. Any of the fringes. Fine. Now, what is meaning of this? What have we understood? Just a quick summary of it, what we are actually trying to figure it out. See, at the center, the fringe that I am obtaining, this is a central bright fringe. Fine, this is known as the central bright fringe. Please understand the physical significance because this has a physical significance. So please understand. So this is central bright fringe. It means linear separation from the central bright fringe right now is what? Nothing. So this will become 0. Fine, yn will become 0, central bright fringe. Now what happens whenever this experiment is conducted, whenever Young's double slit experiment is conducted? So after this very central bright fringe, there is obtained a dark fringe. This is obtained and this is obtained on this, on the lower side, this. So what are these? This is known as first dark fringe. This is also known as first dark fringe. Fine. Now again, a bright fringe will be formed here at this point. And here again, you will obtain a bright fringe. Here you will obtain a bright fringe. So this is known as what? This is the first bright. This is the first bright fringe that has been obtained. This is the first bright fringe that has been obtained. Now what will happen? This will continue. Now you will get a dark fringe, a space, a vacancy of colors. So this will become what now? This becomes second dark. So when I say second dark fringe, it does not mean second one from the central bright. No, second dark means this is first, so this is second. This becomes second dark. Second dark fringe. Similarly, now you keep on continuing this. This here you will obtain the second bright fringe. Here also you will obtain the second bright fringe. Like these, like this, you will be obtaining all of these. So this becomes what? This becomes This becomes second bright. After first bright, you're obtaining second bright. This is second bright. So do you get it? What we were calculating. Now, when I say, suppose I say calculate the linear separation of second dark fringe. It means you are calculating this separation, second dark fringe from the central bright. This is the central bright. This is the starting one. If I say calculate the first bright fringe, so you can calculate any of it. Let's say this is this separation, 5 centimeter, 3 centimeter, 4 millimeter, 2 micromillimeter, any quantity you can calculate. Fine. So this is what we are trying to find out using the formula. Now, how much fringes can you take? How much fringes can you take? No, on your fingertips. Definitely 1, 2, 3, 4. How much can you draw? So you have to figure it out that if even 10th fringe I'm saying. See, there's a difference. 10th fringe means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I say 10th dark fringe, that means 10 sets of dark fringes where bright fringes are escaped. When I say 10 bright fringes, that has a different meaning. This part is clear to you or not? Yes, class. Any doubts you have? Huzefa, Krishna, Kulsum, Sara, Zen, clear to you? Any queries you have in between?
No, ma'am.
Clear? Sara, Zen, Kulsum? Because this has a meaning, so understanding is required. Okay. And
Teacher, the
yes,
above
Fatma.
the central bright fringe and below the both the lengths will be the
Same,
same.
exact same. Yes. So whatever length you will be calculating one of the length, because for both it will be the same only. So that whatever is the separate, because they are formed simultaneously and exactly replica of each other. So even if you take it from above, from below, you have the same meaning, right? And what about you, Akifa, Atif? Clear?
Yes, ma'am.
Okay. Hamza, Hanifa, Hiba, clear to you? Yes, Hamza, I'll explain. See, first you get it. Physical meaning is clear what we are trying to do. This is what we are trying to calculate. Now, when we are trying to calculate this, we have to use the formula. Using these simple formulas, you will be able to calculate. Now, you have this formula for bright fringe. When I say y1 is equal to lambda capital D by small d, it means you are calculating the first bright fringe separation from the central maximum. If I say the way you have mentioned this, that how to calculate like third fringe, for example, you have mentioned. So you put n as 3 in this equation. Instead of n, no, just replace it. Here, when I say y1, this means n is 1. That is the first bright fringe. Whatever this number is mentioned to you, replace that by small n. Let's say second fringe. So 2 lambda d by d. If I say third bright fringe, so that means n is equal to 3. So in this equation, instead of n, write 3. And lambda, capital D, small d, all these things will be given to you. So this will become 3 lambda d by small d. This is for the bright. Now same thing for the dark. Same thing you will be obtaining it for the dark. Like this is the main equation. 2n minus 1 lambda d by 2d. Capital D will be given, small d will be given, lambda will be given. N will also be given because they'll be asking you second dark fringe, third dark fringe, fifth dark fringe. So using that number, you know what is n. And just replace this n with that number. Let's say 3 by 3. So 2 into n. N is what? 3 right now. Minus 1 lambda d by 2d. So 2 into 3 becomes what? 6. 6 minus 1 is 5. So y3 will become 5 lambda capital D by 2 small d. Now is it clear? Hamza, clear to you? Any
Teacher,
doubts
y
here? Yes, Fatima. Yes, Fatima.
y2 should be equal to 3 lambda d by 2d, right?
Y2 in this dark fringe.
Yeah.
So it's 3 lambda d by 2 only. I've written it. This part, no? Yes. So 3 here. See, 3. Fine. 2 into
Is
which one?
down should be 2d, right?
Oh, yes. This 2 will be there. Yes, correct. 2 will be. 2 will be. Because odd one you will obtain. In the dark fringes, mostly we have odd one. That's why we had considered this 2 and minus 1. Yes, Fatma, thanks. Now clear? Everything fine, this topic?
Yes, teacher.
So note it down. Then this was a very major important topic from your interference. Note it down.
Ma'am, can you scroll one line up?
Written class till here.
Yes, teacher.
Okay, next is width of fringe. Now, width of fringe means what? Width does not mean this length or thickness of a fringe. That is different. Width means the separation between two consecutive dark fringes or bright fringes. Let's say this is the separation between two consecutive bright fringe. This is the separation between two consecutive dark fringe. So this length that I'll obtain, this is known as width of fringe. This either dark or either bright. Now, both have the same conclusion, both have the same answer. But we'll solve this, we'll find out the formula, let's say using dark, because bright you will be able to do because brighter's one has a lesser value. No, n is only there. Here you have 2n minus 1 by 2 is also there. So this is denoted by beta. So this becomes what? Consecutive means if this is yn, then you have to subtract yn minus 1, just the previous one. 3 hai. So 3 minus 1, that is 2, like this. So same thing here, we'll keep for the formula. Let's say dark fringe, I'm taking just the example. The final formula will be same for dark and bright fringe. For bright one, that you can calculate after the class. You'll see both the answers are same. In the exam also, if specifically bright is asked to you to show the derivation. Same thing you have to do. Here we are writing the expression for the yn lambda d by 2 small d minus 2. N is there. Here your n is what? N is n minus 1. So this is n minus 1. 2 n minus 1 lambda capital D by 2. Do you get the difference why there is n minus 1 minus 1? This is 2n minus 1. Here your n is n minus 1. That's why 2n minus 1 minus 1. Now we just have to solve this. So this will become what? 2n minus 1 lambda d by 2d is there. Some things we can take common. Lambda capital D by 2d, we can take this common, right, from here. Lambda capital D by 2 small d, I think we can take common. So this is 2n minus 1. From here, we'll obtain what? Again, minus 2n, then that this minus 2n minus 1. And if we take minus sign already from there, that makes it plus 3, right? So beta becomes 2n, 2n gets cancelled. 3 minus 1 is what? 3 minus 1 will become 2. So 2 lambda capital D by 2d, 2 gets cancelled. Beta's formula is lambda capital D by small d. So for bright, dark, any fringe, this is valid for both. Even if you use the same thing, no, using bright one, same thing you will obtain for the bright one. One more topic, 3 topics, let's do. One is this, that is the fringe width. In continuation is this. Is the angular fringe width. Now, what is meant by angular fringe width? Angular fringe width means this is your central bright fringe. So the angle that the central bright fringe subtends at the center, this is known as angle fringe width. Fine? Angle fringe width. This is slit 1, slit 2, some source will be there. Central bright fringe, whatever angle is being subtended, this angle is very less though, but whatever angle is being subtended, that is known as angular fringe width. So what will be this angle? Angle is always length of arc divided by the radius of arc. So theta will be equal to beta. The length of arc is what basically? The separation between the fringes, that also you can take. So beta by capital D is the formula for this. So even you can use this, or if you want, you can put theta as beta's formula, lambda capital D by small d. And here you have capital D. So theta's another formula is lambda by small d. This is also one important formula. Both are important formulas. All these that we are doing, all these are important. What is less important that I mentioned you. And last thing that I want to mention is beta is clear. Fine. Now, if suppose I change the medium, instead of keeping this in air, let's say I have kept this entire apparatus of Young's double slit into some medium which is having refractive index n. So beta in air is lambda capital D by small d. If some medium is there, then this lambda capital D by small d gets divided by n. Fine, this gets divided by, this is the formula for it. So sometimes what happens, we are just given the main formula for it. So if we are given the main formula for it, so beta in any medium, main formula means beta in air is given. So it means beta in air divided by n will be the formula for it. Now, what all questions can come specifically from this part? Why have I mentioned this very specifically to you is that beta can be asked to you directly using formula lambda d by small d. It can be said refractive index is, let's say, 5, calculate the beta in some medium. That also you can do. Otherwise, from this theoretical question can be asked, like if an apparatus of Young's double slit experiment is kept in some other medium which is having refractive index n, what will happen or what will be the consequence of this on the beta in that medium? So it means you will have to mention this term that it will decrease, because this is getting divided by refractive index. N is, let's say, the refractive index. So this is getting divided. So that's why it will ultimately decrease. So 3 topics just now we discovered. We discussed separation between any 2 consecutive fringes, any 2, 5th, 6th, any 2 consecutive same fringes, like dark, dark, bright, bright. That is known as angular fringe. That is known as fringe width, whose formula is beta is equal to lambda capital D by small d. Capital D is the separation, small d is the separation between both the slits. Then we did theta. Theta is the angle that is subtended at the center. So angle that was subtended at the center means the angle that is subtended by the bright fringe, by the central maxima. And central bright fringe is always there. That is, either you can write it as beta by capital D or lambda by small d. Lambda by small d is also used a lot. And third thing we discussed, that if entire apparatus is kept in some other medium, it is decreased and it gets divided by the refractive index. One numerical we'll do, but before the numerical we do, let's just copy all these points. Then we'll do a question, formula-based question on this. Okay, this question says that lambda is given, small d is given, capital D is given. Actually, in the main question, no, the figure was also given. So small d and capital D you had to identify on your own. So I've written it separately. So in your exam also, you can get separate figures as well. So from the figures, you have to identify what is capital D and what is small d. So capital D is separation between both the slit and the screen, and small d is the separation between both the slits. So this is 6,000 angstrom. Separation between the slits is 10 millimeter, and the separation from the screen and the slit is 5 meters. You have to first find out the linear separation of bright fringe from central maxima. So it means same Y formula we'll use, but linear separation of second bright fringe is given. So now you know N is 2, second bright fringe. So linear separations formula for bright fringe we will use. It means Y is equal to N lambda D by D. So first part, Yn is equal to N lambda capital D by small d. And what is N given? N is given to you second. And why this equation? Because bright fringe. So second bright fringe is linear separation. Also, before I write this. Let's convert these quantities, no? Lambda is 6,000 angstrom. So this is 6,000 into 10 to the power minus 10 meters. So lambda becomes 6 into 10 to the power minus 7 meters, right? Small d was 10 millimeters. So 10 millimeters will become 10 into 10 to the power minus 3. That is 10 to the power minus 2, and capital D was 5 meters only. Now we'll put it in this formula that we have Yn is equal to lambda capital D by N lambda capital D by small d. Yes, so N is given as 2. So Y2 will become 2 lambda. Lambda is, what was lambda? 6 into 10 to the power minus 7. Capital D is 5 by small d. Small d is 10 to the power minus 2. Right? Yes. So this becomes what? 12, and this is in 560. So 6 into, so this becomes 6 into 10 to the power minus 4 meter, right? Just correct me if the calculations I'm doing it incorrect, because I'm doing it orally. Second part says same thing just for dark fringe. It means N is same, but the formula we'll use will be for the dark fringe. So for the second part will be Yn. This will be equal to 2n minus 1 lambda capital D by 2 small d. And N is again here 2. So Yn will become what? 2 into N. N is 2 minus 1. Lambda is 6 into 10 to the power minus 7. Capital D is 5. This is 10 to the power minus 2. And here we have 2. So this becomes 4 minus 1. That is 3. 3 by 2. Okay, so here we have 5 into 6. N was what? Sixth bright fringe or third bright fringe? This one. No, so 5 into 6 into, not 5, 3 into 6. So this becomes 3. 3 into 6 into 10 to the power minus 7 into 5 by 2 into 10 to the power minus 2. So this will also become 3, 9, 5, 45. So this becomes, Yn becomes 45 into 10 to the power minus 5 meters. Now third part was asking, I think the fringe width, no? Yes, fringe width. Third part says fringe width. So fringe width, beta is equal to lambda capital D by small d. Lambda is 6 into 10 to the power minus 7. This is 5 by 10 to the power minus 2. That makes it 3 into 10 to the power minus 4, it will become the 30 into 10 to the power minus 5. So that will become 3 into 10 to the power minus 4. I'm saying if somehow one more part, yes, in the fourth part you have theta, that is just lambda by small t. That will be simply 6 into 10 to the power minus 7 by 10 to the power minus 2. This will be 6 into 10 to the power minus 5 radian. Now what I'm saying, somehow let's say refractive index is given to you as 2. This is the additional part that I'm saying. So beta in air is this. So beta in this medium will become what? Beta in air by refractive index. That is 3 into 10 to the power minus 4 by 2. Got it? That is 1.5 into 10 to the power minus 4 meters. This is just additional part if somehow you have the refractive index as 2. Fine, if somehow you all have the refractive index as 2. Clear? Formula based it is. Okay, do one thing. Note down questions. Question all of you have written, or do you want to write down the question? So if you have written the question, then write down the solution. Okay, one small topic, that is sustained interference. This comes as a 2 marker, that's why I've written it separately. And if it comes, no, then you have to write it as it is. Now see, in case of sustained interference, what happens? Usual no normal interference. In normal interference, if you apply the source and the source radiates out the waves, then what happens is that you obtain in the center the central bright fringe, that we call the central most bright fringe. And then you have the dark fringes where intensity is low. Then you have bright fringe, and so slowly it keeps on fading away at the end where you obtain all the fringes. In case of sustained interference, if your waves are produced from a coherent source. So in case of sustained interference, bright and dark fringes have a very good contrast, that it won't be difficult for you to identify, yes, this is the dark one, this is the bright fringe. Otherwise, in normal interference, no, that is done by the Young's double slit experiment. That is done in the Young's double slit experiment. There you have to identify, yes, here the light is missing, so this is the dark one. Here the light is very bright, this is the bright fringe. In case of sustained interference, you will continuously throughout see all the bright fringes bright, and in between all the dark fringes very clear. So intensities do not change. In case of the normal interference that we have, non-sustained interference that we were discussing, intensity gradually decreases, fades away. Lighter one will you see at the center where the light is striking away, centermost part, central bright fringe, it is the brightest, and slowly it fades. But in sustained interference, intensity does not change. It will remain as it is, clear, shiny with good contrast. Now conditions are there. Firstly, sources should be coherent. Coherent and non-coherent we have done, no, phase difference should be constant. All the conditions, wavelength and amplitude, all these points, frequency should be same. Monochromatic source light should be there. Light waves, no, I've written the conditions also, I think, yes. So conditions, sources should be coherent, sources should be monochromatic. It's producing a single light. Otherwise, what will happen if white light or some other light is used, that I'll tell you right now. And slit width should be maximum. This separation should be much, and even this separation between the screen and the slits, this should also be large. Then there are chances that sustained interference and a good interference can be obtained. Now, from your exam perspective, a theoretical question will come, write all these points, definition along with the conditions. Now, what will happen if suppose, let's say, a white light is used, not a monochromatic light is used. Let me show you if white light is used. See, dispersion we have already studied. If somehow white light is used, no, so white light is just composed of all the 7 colors, right? White light is made up of all the 7 colors. So if white light is used, then all these 7 colors will be produced like this in the form of rim. I have not written all the colors. This violet and this red indicates that in between all the colors are present. Here also you will be having all the colors. In which form? It means simply in the Vibgyor form, same form of Vibgyor that you have. Here at the center, white light will be produced at the center. Why? Because all the 7 colors from here and all the 7 colors from this path, like this 7 colors and 7 colors from this path, all are coinciding at the center. Do you get this? Dispersion we have already studied. So in dispersion, what happened? In case of dispersion, in case of dispersion, this white light was made up of all the 7 colors. So when it passed through the prism or any glass material, it got separated. Now what is happening? White light is there. So 7 colors will initially be separated, but then they'll coincide and form the white fringe. So this fringe's color is known. And now what will happen? In the Vibgyor format only, here you will obtain a violet, here indigo, here blue, here green, yellow, orange, red. And same thing here also, violet, indigo. Because both the things that are present above the white fringe and below it, both are same. So like this, Vibgyor, like this, it will continue. This is what happens if you have interference with white light. If you just have monochromatic light from coherent sources, that results in sustained interference. So on using white light, central bright fringe would be white, Next fringe would be violet, and after few bright fringes, pattern disappear due to overlapping because intensities do not remain the same. Whereas where we were discussing interference, sustained interference, here the light rays, the intensity was of each fringes that was formed, it remained fixed. If I note down sustained interference and this interference with white light, then one last topic will be there for today's class. That is intensity distribution curve. So that curve is also important, but just these two theoretical points, write it down.
Ma'am, can you show the conditions once more? Done, ma'am.
Done till here? So I'm starting with an intensity distribution curve. Okay, all of you have completed. See, intensity distribution curve is very easy. If it comes again, same theory part. All this is a part of theory only. Sustained interference, interference with white light, intensity distribution curve also. So coherent identical sources, if you have coherent sources are there and identical, they are identical. It means intensity will be same, quantities will be same. So for bright fringes, resultant intensity will be under root I1 plus under root I2 whole square. This is the formula for bright fringes intensity. So if I1 is equal to I2, then I can be written as 2 times this under root I1 whole square. That makes it 4I1. So I is equal to 4 times I1 in case of bright fringes. Hold it right now. I'll explain it later. How is it related to your curve? This part is just mathematics. Now coming to the dark fringes, same thing, but a negative sign will come. I is equal to under root I1 minus under root I2 whole square. I1 is equal to I2, so this will get cancelled. I is equal to 0. How will you plot it on a graph? I'll show you. Before that, non-coherent sources. Yes, see it for the non-coherent sources. See, non-coherent identical sources are there. So for non-coherent, we'll use the complete because your phi is variable, phase constant is variable. No, that was the difference between coherent and non-coherent sources. In case of non-coherent sources, now your phase difference is variable. So this becomes I1 plus I2 plus 2 under root I1, I2 cos phi. So when we have variable quantities, the way in AC, we had variable EMF, we had variable current, what did we do? We calculated the average of it or the peak value we chose. But average we found if we had to tell what was the EMF of the circuit. So same thing, we'll find out average resultant intensity. It means this entire term that we have, this is the average. So when you're calculating the average, you cannot calculate the average of this part, I1 plus I2 plus 2 under root I1, I2 using two quantities. But cos phi's average you can calculate. Fine. So whenever you have cos phi, no, the average of cos phi is 0 always. So it means this entire term will become 0. So what will be the average intensity? Average intensity will be equal to I1 plus I2. So is there any phi now in your answer? This, if I say this is the resultant intensity, is there any phi? No, this is independent of phi, independent of phase difference. Now let's plot the graph. For coherent sources, maximum value for the bright fringe was 4i and minimum was 0. And non-coherent is independent of phase difference. If I plot the graph between current, that is intensity, and the phase difference, this will be what will I obtain for different phase differences, the coherent graph. This is what value? This is 4i, the maximum. Then for dark fringe 0. Then at this phase difference, again the same maximum value 4i because this is a constant value 4i. Then again it decreases, then again 4i, then 0, 4i, 0. This graph will be obtained for coherent. And phase difference graph versus intensity graph for a non-coherent source, it is independent, so a complete straight line. All this is a part of your theory, so it will come, you will have to mention all these. Quickly note it down. This you have noted. Any doubts you have in between, you can ask me. And as you'll complete, do text me done at the end because this was the last topic for today. Now, 2 questions on interference we'll do and diffraction is left. Diffraction is smaller topic, not such huge like interference. So those who have completed, you all can leave. We'll continue this in the next class then.
Yes, ma'am.
Thank you, teacher.
Slits on a sheet of paper. Slits, you can just check YouTube once. Hamza, I'll send you certain videos also on WhatsApp. I just text me once. Fine. So YDSC project, some things that you can see from paper, I think it will be difficult. But from comb or something where it already slits are there, that you can use comb and paper using that. Do search it on YouTube as well. Okay, those are difficult to perform at home. Okay, staples, electrical tapes, these are required. Fine, then Hamza, if it is difficult, though I think some of the students did it last year. Otherwise, then if it is becoming very difficult, I'll also search one, then I'll let you know. Otherwise, then change the topic if you have sufficient